Saxon's Calculus, Lesson 78, is about integration by parts. And we start off with giving you the formula for what happens when we are trying to integrate two things that are multiplying together. So when we were deriving, we had the song to help us. But when we're integrating, we're going to have a box that will help us. So the formula that you need to do is understand that when you have the parts that are multiplying together, you're going to do in the box form u times the v, which happens to be the top two boxes, with the integration of the v du, which are these two. Now, when you take the originals to fill into the box, so this will be always the u column, this will be the v column. Your original boxes that you will fill in are this one and this one, and then you will work out this one and this one. Okay, so I'm going to restart here with this example 1. They give me x with sine x dx. So the first part is the u, that will be the x. Then the corresponding, and you just have to label it the dv part, knowing that it's always that way, is the sine x dx. So these are the originals pulling from what you're given. What is the derivative of u? Well, that's the derivative of x, which goes to 1, and then we fill in the dx. Working backwards, how did we get sine? We got sine from negative cosine x. And now we're going to put it together, excuse me, sorry, in the formula. So u times v is going to be negative x cosine of x minus, and then the integration of v and the du. Now this du is dx, and so all that's really doing is putting the tail end of what you need with this. Sometimes there's extra pieces in here, sometimes it's just the extra part that you need. So you're integrating negative cosine of x dx, basically. So now you put the finishing touch on what is the integration of negative cosine. Well, where did that come from? It came from negative sine, and then this negative negates that, so you're keeping negative x cosine of x plus sine of x plus c, because we had an integration part. Negative x cosine plus, yes. All right, let's look at example 2. Find the integration of the natural log of x dx. So in our box, we will have our u equals, our v equals, our dv equals, and our du equals. So our u is going to be the natural log of x, because that was the first part. And then the only thing left for the dv part is the matching dx. Now, if I work backwards, how did I get a dx? Well, that came from an x, so v is the same as x, and then deriving natural log gives me 1 over x dx. Okay, so now there's all my parts, and now we follow our formula. So u times v will give us x natural log of x minus the integration of v du. So that's going to be x with 1 over x dx. Now x times 1 over x cancels off and just leaves me dx. So the integration of a plane 1 goes back to x. So we keep our x natural log of x minus the x, because that was 1, so integrating back takes us to x, and then we always have with our integration plus c. Now example 3. Integrate x e to the 2x dx. So we form our box. our u equals, our v equals, the dv equals, and the du equals. So the first part for the u is x. The second part for the dv is e to the 2x dx. And now the derivative of x goes to 1, so just the dx basically, and then working backwards, e to the 2x comes from, and I don't want to do my work in this box because e to the 2x comes from e to the 2x, but I also have to deal with the 2x, which gives me a 2 in front with it. But that's not a part of this original, so I have to undo the 2 to not have it here, which means that I make it 1/2. So now you get your 1/2 e to the 2x. And that's not the one that gets the dx. Okay, so now we follow our u times v. So x multiplying with, so since it's multiplying with, I'm going to put that half in front. So 1/2 x e to the 2x minus, and then we need to integrate 1/2 e to the 2x multiplying with our dx. That just adds there what it's supposed to have. All right, so rewrite this part, no change. And then this becomes e to the 2x is still, okay, e to the 2x, yes. And then because I had the 2 from the exponent, that makes it another half in front. So we get minus 1/4 e to the 2x, and then our plus c. Yes, okay. Example 4, integrate 2x sine x dx. Box. U equals, v equals, dv equals, du equals. The first part is 2x, and then the second part is sine x dx. Derivative of this one goes to 2 dx. And then working backwards, where does sine come from? It comes from negative cosine of x. It does not need the dx. So now the formula, 2x times negative cosine. So I'm going to put the negative in front, and then cosine of x minus the integration of v, which is negative cosine of x, with a, okay, so 2 should go in front there with the dx at the tail end, just putting those two together. So then rewrite negative 2x cosine of x, and cosine came from sine of x, and the negative 2 was a constant that still needs to be there, and the negative with the negative makes it positive, and the plus c at the end. Is there another example, or is that it? No, that is it.